This is a short tutorial on how to interface RAM in Proteus simulation file. Our objective is to copy the contents of this ROM to this RAM. To do this, first we need the contents of this ROM. For this purpose, we open a text file, write down some hex digits in consecutive lines like this, then save it in .bin format. The name can be anything, but the format should be .bin. After doing this, we go to the program ROM, double click on it, browse for the code.bin file, then we write here comma ASC hex. Okay. Now the bin file is now inserted in the program ROM. Now we see we have drawn here a 16-bit counter. This 16-bit counter provides the address of this ROM and this RAM as well during writing data from the ROM to RAM. After writing finished, to check whether the data is correctly saved in the RAM, we get the address of the RAM from this part. For this purpose, we have used a multiplexer which selects during program loading the address come from here, from the counter to the RAM, and during checking whether the data is saved correctly or not, the addresses come from this logic states. The purpose of the multiplexers are for this purpose. Now, when the address from the counters are available here, the contents of that address of the ROM is also available here. Now this data is sent to the IO port of RAM for writing at that address. The same address is now here also at the RAM also. Now we see this is the clock which is supplied at the counters of the program ROM. In this case, at this positive edge of the clock, both the address and the data of program ROM are available. Now to write this data to the RAM, we need the write enable pin to be lowered in the RAM. So it's lowered here. Now before coming another address and data to the RAM, the datasheet of RAM suggests that the write enable pin should be disabled between this time. Now the data and the address is available in the next positive clock pulse. Here before this we have disabled the write enable pin of RAM. Now when data and address for the next phase is available, we again make the write enable pin lower, that means enable it. So we see the clock supplied at the counter of program ROM and counter and the clock and the write enable pin of the RAM is inverted. So the clock supplied at the program counter at the counter of the program ROM is inverted to supply the clock and the write enable pin of the RAM. We have done the same thing here. The clock, the same clock which is supplied here, its inverted version is supplied in the write enable pin. Now we start the simulation. At the beginning of the simulation, we should reset the counters, make this out in pin 1 so that the address comes from here. During program loading, we should get the address from here. Now we start auto loading. Our file that was written in the code.bin file was very small, and by this time it has been already copied to the RAM. So we make this auto load 0. Now we have to check whether the data is correctly written to the RAM. For this, we need the address from here now to check the data at that address. So we make this button 0. Now we check In our port.bin file, the first data was 03, means at the 00 address of the RAM, the data should be 03. Let's check. Here the address is all 0 and the data here is 03. The first 4 bit is 0 and the last 4 bit is 0011. That means 3. So it was 03. Now in the next address, the address is 0001. We check for it. Its first 4 bit is 0. Next is 0110. That means 6. The data is 06. We have written here also 06. So we see that our data is correctly copied from the program ROM to the RAM. This is about interfacing RAM in the Proteus simulation. We can add more logic gates here for interfacing RAM in other complex situations, but the basic principle is like this. Thank you.